Example number 5. All right, so for example number 5, we're asked to figure out if something's increasing or decreasing, and when does that occur? Well, we know that by looking at the graph, right? So consider this function here. All right, and our task for example number 5 is to determine if it's increasing or decreasing, but we're going to have to use some sort of calculus to figure that out. All right, so if I look at the graph, this is a parabola, right? We've memorized this. This is a quadratic. It's a parabola, and it goes through the origin, and it kind of looks like that. It looks better when you graph it on a calculator than when Mr. Adams draws it. But when is it decreasing? Just tell me by the graph. From what to what? Yeah, it from negative infinity to 0, right? So it's decreasing from negative infinity right on up to 0. And I don't know if we should include 0 at like a bracket. Probably, because it does increase up to 0. Or I mean decrease to 0. And then it increases from 0 to positive infinity, right? Where this is infinity and this is negative infinity. And we're referring to the x, right? When we talk about the domains, we're referring to the x's, right? Yeah? Yes. Yeah. So now, we see that it's increasing, but what's really going on? Think in terms of physics. Or not physics, AP Calculus. If we think in terms of AP Calculus, at any point on the curve, if I were to draw a tangent line, what do we know about the tangent line?
The slope's going to be negative and then go to positive.
Yeah, so right here, f prime of x is always negative, right? Now, if we go to the right of 0 and we draw the tangent lines, we see that f prime of x is always positive. Okay? What happens in between positive and negative? Well, right here when x equals 0, our tangent line, f prime of x is equal to 0. Right? And that's why we talk about minimums and maximums. Because you probably the last couple sections, you're like, oh, who cares about the minimum and maximum? If we just want to know the max and the min, the extreme or global maximum and the extreme or global minimum, why do we care about all this stuff? Well, the minimum and maximums are also where there's a change in the function behavior itself, where it goes from increasing to decreasing or decreasing to increasing. So to solve this algebraically, I just need to think of this as f of x equals x squared. Then we know that f prime of x is equal to 2x. And that means that f prime of x is equal to 0 when x equals 0. Now that's algebraically. I threw the graph up there so we can wrap our minds about it, but technically we're supposed to be able to do that without the graph. Okay? I went kind of fast. Did I go too fast? Do you guys have any questions on that?
No.
Does that make sense? Okay. So now, how do we figure out if something's increasing or decreasing? So this is a simple function. If we were to do like a complicated polynomial, there would be several zeros, right? And we'd have to test each 0, and probably what happens is the function goes up and down, increasing, decreasing, increasing, decreasing. Okay, so we're gonna start with something simple. All right. So what I do is I draw like a little grid here, and I say x equals 0. So that's neither increasing nor decreasing when x equals 0. And there's a couple of things that we could do. Well, what we want to know is the f prime value. So I said that f prime of x is equal to 2 times x. So I arbitrarily choose a number, like x equals -1, and I evaluate f prime of -1, which is 2 times -1. And you know what? I don't even care if it's -2. It is. I don't care. I only care if it's positive or negative, and guess what? It's negative. I do the same thing over here. F prime still hasn't changed, so it's still 2x. But now I'm going to arbitrarily choose a point greater than 0, 1. And so I'm going to evaluate f prime at 1, which is 2 times 1. I don't care that it's 2, although it is. The only thing I care about is if it's positive. So we looked at the graph. Now we're doing it algebraically, analytically, and numerically. What does that mean? Well, when this means that the slope is negative, right? So it decreases here. That's not how you spell decrease. It decreases here and increases here because the slope is positive. Does that make sense? And so that's the algebraic justification for this information right here. Why is it like this here? Because f prime of x is negative. Why is it like this here? Why is it increase here? Because f prime of x is positive. Now there's some more formal definitions. It talks about as x increases, the y value increases. That's how we define an increasing function. And then the same thing, as x decreases, the y value decreases. Or no. I said that backwards. As x increases, the y value decreases is the formal way to say it. But do we have any questions about this? What I've written down? No? Okay, good.